Hello, I'm Adrian and I will show you today how to make a plasma ball-like effect with particle flow. So I will only show you the technique and not the final render and simulation, because it's slow. It's calculating slowly, and I don't have time right now for it. So I'll show how to make it, and then you can play just with settings and render it as you want. So let's start. First we need to create a sphere that will be our bounding sphere for our plasma. So this will be the ball itself, glass ball. So let's create a sphere. Now press W to select a move, and right click the spinners of the position to move it to center. Okay, so this object will act as our collision object, so the plasma will fly and hit it and then move on its surface for a certain time, then will disappear. So we don't need to see it now. So we need to see through, because we want to play inside it. The simulation will go inside, so we need to see what's happening. So right click on it and go to object properties and check the see through the checkbox. Press OK. Now let's change the viewport to shaded, so we'll not have the nitrous calculating with transparency. Okay, now let's duplicate this sphere by pressing Ctrl V, or by going to Edit Clone. Set it to copy. Let's name it emitter. So this will be a smaller sphere that will emit our particles somewhere here. Okay, now for the collision to work, we need to invert its normals, so it will face inwards. So select the big sphere, go to modify list and type normal. Pick the normal modifier, and you see it by default it's flip normals is enabled. Okay, so now the normals are facing inwards. Now let's create our particles. So press 6 to bring the particle view in front. If you'll press 6 and nothing happens, then you need to enable this keyboard shortcut override toggle. Okay, let's create a standard flow. Select the position icon, press shift and select speed, rotation, shape, and right click and delete them, because we don't need them. Now how this setup will work, we'll emit some white particles on the sphere that should be attached to the sphere. So the sphere emitter will be animated, and from those particles they will be emitted the plasma particles that should fly around. Okay, so let's start by creating by adding a position object operator. Position object. Okay, let's set the birth to emit start to 0, emit stop 0, amount for now 5. So we'll have 5 guides. Position object will be so press add and pick our emitter sphere. If you accidentally if you can't pick this sphere because of this bigger sphere, just zoom inside of it and pick the smaller one. Okay, now let's lock on the emitter. So we'll want to animate the sphere, so we'll have a nicer animation. Now go down, location surface, and check delete particles if location is invalid, so we don't have some our particles which we don't need. Okay, so now we have guide particles. Let's create let's animate the smaller sphere. So we'll have I will animate it later, just to show you what will happen. So the difference. So now we have the guides. We need to emit from them, to spawn from them the plasma particles. So let's put a spawn operator below the position object. So set the spawn rate and amount to per second. Let's set the rate to 100, but later we'll set it to some bigger number because we need more particles for good Krakatoa render. And go down and set the speed variation to 10%. Okay, so this if we will look now what's happening, we don't see nothing because the particles which are spawned particles are at the same place of parent or guide particles. So let's set a force operator, because we want the new particles to move in a spherical turbulent fashion way outside. So for this we'll use a force operator, and let's connect the spawn with force. And for the force we'll create a wind force. Yes, wind force. Okay, so let's create the wind force. Again, press W, go through X and Y by clicking right click on the spinners to make it in the center, to move it in the center. Now we need to set the type to spherical, so it will push not in a direction, one direction, but in a spherical way. So let's add it to our particle flow. Select the force operator, add, and pick the wind space warp. Okay, so now we'll play the animation. You can see that we have something, but we don't like the movement, it's linear. And also if we will play the animation, you can see that they are very fast. So let's set the range to 0.2. Okay, now they are slower. And let's set the turbulence to 0.3. You can see that we have now some turbulence going on. Now for the scale, the smaller the scale, the more longer noise turbulence type you'll have. So if you set it to 0.1, you now can see what's happening. To see better, let's set the frequency. Frequency will respond to how much how frequently will be this turbulence applied. It's like scaling a noise map. So at a smaller scale, the black and white will be closer, so we'll have different patterns, more stretched patterns inside. If at higher, at the lower frequency, it will have more smooth longer patterns. So let's set this to 0.1 and see what you have. Okay, it's looking good, but let's increase this to 0.2. Okay, so I'll get some nice results, but looks like the scale is too low. Let's try to increase it 0.2. Okay, now we have some more randomization. Okay, you can increase this if you want, but we'll leave it for now 0.2. Now let's animate the sphere, so we'll get a nicer movement, like the quiet particles are moving on the sphere. So select the smaller sphere, emitter sphere, press E to go to set it to rotate gizmo. Now press Alt key and go to some frame, rotate it, not too much because you'll have much noise in those lines. Go to our frame, again rotate, like so. Okay, let's see what we have now. You have nice animation. Now we want them to collide with the bounding sphere. So for this we'll create an deflectors, a simple deflector. Oh, sorry, U deflector. Pick the bigger sphere, set the bounce to 0, and now let's go back to particle flow and set a collision test operator in the event 2. Okay, so let's pick the deflector. So set the speed to continue. I don't think it's matched, but anyway, we don't want them to stop because it will move on the surface. Now if you look, you don't see nothing because the speed continues. Let's bring them to a new event that will follow the surface of the bigger sphere. So for this, let's speed by surface, add operator speed by surface, connect them. Okay, now select this surface by pressing add and picking the big sphere, and when it will collide, it will set the speed once, so they will go outside of it. So for now the speed direction is by normal. We want them to be parallel to surface. Okay, so you see that it's setting the speed just one time, but we want to be every time control speed continuously. So let's so we will decrease the speed. For now, you see that the speed is very big. Let's decrease it to like so. Variation 10. Also we see that it's offset a little bit, maybe because of this collision. Let's make it stop. Okay, now you can see that it's moving around. Also we want to delete the particles after some time, so let's pick the delete operator and set it to by age, lifespan 15 and variation of 10. Okay, now the particles will collide, will move around, and then will die. I think if the speed is big, let's set it to 20. Okay, like so. So we have the basic setup. If you want to increase the number of bytes, you can increase it here in the birth operator. Also the number of the plasma particles, to change it, it goes through spawn operator and change the rate to a bigger number. Okay, so for wind, just go to the wind space warp and change the parameters as you want. So to increase a little bit the performance in viewport, let's change the display type to dots. Like so. Okay. Now we'll set up the Krakatoa rendering. So let's decrease the number of bytes because we'll use more particles. So let's set this to 3. Go to Krakatoa and set Krakatoa as current rendering and open Krakatoa graphic user interface. Okay, so you can use lights or other thing, like setting a light inside and light the particles, or you can use force additive mode, which I will use in this example. You can see that we get some results. Let's increase the particle count. So I'm pressing F9 to render quickly. So you can go to rendering, render setup, and render shift Q. But it have a little bit, it behaves a little bit different than F9. So if you have some save file, if your rendering is saving on the disk, when you'll press F9 it will not save the current rendering, and if you press Shift Q it will save what you will render. Okay, so let's increase the spawn rate like so. Let's see what we have. Okay, we have a nicer look. Also we can play with density, motion blur. Like so. Also you can use the vector rendering type, the voxel rendering. So let's set the voxel size to 0.1, filter radius to 2 pixels, and then final pass density to 1. Let's see what we have. Okay, let's remove the motion blur. Let's set the voxel size to something. No, let's let the voxel size to be 0.1, the final pass density to 0.1. Okay. Also, I want them to be more smooth, so I'll use the filter radius. I'll increase it to 5. Maybe like so. And let's see what it will look with more particles. Like so. So for the best render you'll increase, for final render you'll increase the number of bytes, but not too high because it will be a mess. The spawn rate, something very big. Okay, so this from the part of particle flow. From part of Krakatoa, you will choose what rendering type you want to use: voxel render, particle rendering, the density. Also, when from particle flow, when you'll want to preview the animation with more particles, just go to the path source 01 and decrease the viewport count for faster updates. But don't forget that it will decrease also the guides count. So find something reasonably. Okay, so set these settings as you want: the voxel size, filter radius to get more smooth results, more points if you decrease it. Final point density. Also, you can use lights, set a light inside, and so you'll have a nice light gradient. And also you can use the color technique from my other video to color by age, by creating a new channel and using the age, the same technique as in that tutorial, color by age. So age and lifespan. So you can color by texture or other coloring technique or shading. So let's divide this. I'll show you a quick example. Divide the age by lifespan, and we'll get a number from 0 to 1. We want to blend two colors. We use the blending creation, we divide the result. Okay, let's set the starting color like so, ending color like this. Okay, let's see what we have. And I'm not sure that if this is a problem, but when the particles are in even true, so those violet particles are in even true, I don't think they have age data. So I'm not sure. So if you'll see that the shading is not affecting the particles inside the ball, just make a clone of delete operator here in the event true. So by pressing shift, just moving it here. I will not do this now. So we will set it instance because I'm not sure. Let's add a curve just to see what's happening. Okay, so function curve, so we'll pick our divide and okay, like so. And for the curve we'll create a point, set it to smooth, like so. Also I will decrease the for the test I will decrease the particle count to get faster update, and also I'll decrease the particle age, like so. Let's press F9. Okay, it's hard to see because of low particle numbers, so let's just decrease the guides to 1 and spawn more particles. Okay, looks like doesn't work. No, it's working, but only at event 3, maybe. Okay, looks like event 2 doesn't have age channel. Let's make what I've said. Okay. Just vacated instance. Okay. Let's see. Okay, now it's working. So the problem was that as I said, that age and lifespan channel they wasn't created before the event 3. So let's set this back to linear. Let's see. Okay, now we have some nice gradient. So that's all. Just increase the setting, play with the settings, and you'll get something interesting and render the animation. Thank you and goodbye.